In this segment, we will take up a problem, in fact the same problem of addition of n numbers, and we will see how we proceed with the method which we discussed, that is the bucket and steps method. Okay. That means now we are in a we are required to find say this up to say 100. Okay. Now then what happens is we have to first think that what are the repetitive steps. Suppose we have a bucket and we will keep the one there. Okay. Let me take a bigger bucket. Okay. So because we will put things there, we will keep on adding things there. So that's why the bucket size needs to be a bit bigger, and then I need a bucket to even count my steps. Okay. Then I'll start maybe with an empty bucket, or I can start with say this being there, say 1. Okay. We will see that either of the either of these choices is equally good. So slight changes needs to be done once we go further, if we take empty or the non-empty bucket. Okay. Now, so don't worry at this point of time, please do not worry much about whether to start with empty bucket or with 1 and all, because these detailings will stop you from proceeding ahead. So start with something, and then we will write, based on this we will write a sort of very informal algorithm, and then even at that point you won't be very confident that that will completely perfectly work at the program level. Once we convert that informal algorithm into a program, and then you will realize that there might be some mistakes in your thought process, and we will sort them out. So that's how, in fact, always you should think about a problem. Do not get too much involved with these kind of small detailings. Okay. So let's start with 1 and 1, and I'll put say steps like this. And as soon as we start like this, so because this, I'll give some names to the buckets. Say this is bucket 1 and this is bucket 2. Okay. Now, and this is keeping the track of my steps, and this is keeping the storage of this whatever I'm adding there. Okay. Then suppose now I have this, so I have to check whether I'm already done, because sometimes suppose the question was only to add up to this, so then you are done. Okay. There is nothing to be done further. But then if you are not done yet, then that check has to be done. Now say suppose I'll make a check. Now what do I check? I'll check that whether this bucket has the number 100, because this is counting my steps or numbers which I have putting in. Okay, let's say that these are not the number of steps of addition, but these are the numbers which we are taking and picking in this thing. So that's why this one, because we have already taken this here, so this is that number 1, that one number we have chosen and put it there. Okay. Now, so this will ask whether this number is it equal to that 100? So the answer is no. If the answer is no, I'll have to the go next step, where again I will say draw the bucket, and this is my bucket, and here I will say one was here. I will put the second one by bringing in that. Okay, the second term I'll bring in and then put it there. But then how do I know that 2 is the number which I need to put? Because once we go to this step, we in fact forget what was at the previous step, right? So that's why you can pretend that this you did this the previous week, and now this step you are doing this week, and you completely have forgotten about what was the previous step. Now how do you know that which number needs to be brought from that? So that is the number you will get by adding 1 to this number. So that is a part of your repetitive step which you have devised so that every week it will work, and you don't have to remember anything where you had stopped or any such thing. Okay, so now what you will do is the number which you want to bring into this bucket is equal to this number plus 1. Okay, so now here you are actually not bringing this but bringing this and adding 1 to that, and this is the new number which you are pouring in here, and you are now increasing this here. Okay, so that means the number of steps in okay, so it has become now 2. Fine. So because you have added that 1, so in the previous segment we were putting balls there, so now I have replaced that balls with numbers, so that slowly we will get into more and more formal things instead of intuitive things. Okay. Okay, now so that is now done because we know how to add numbers. So this will become 3 and this has become 2, and then this week we have stopped our work, and again we will meet say next week to do the same repetitive process, but again we don't remember where we had stopped. So that means we just have these buckets again, where 1 plus 2 is already there calculated equal to 3, and this bucket is having 2. Now we should ask again, do I need to do this week or the work was already completed? So again the question is whether it's done. So I'll compare this with 100, and then I'll say no, it's not done because this has to be 100 at the end. So then what again I'll do is this 2 I will take and add 1 to that, because this is the repetitive step which I have chosen, that every time I'll bring up this step, I'll add 1 to that, and this number I will put in there. Okay, so this came a bit so like this, okay, so plus 3, so this is equal to 3, so I'll add that, and here instead of 2 again it will become 3 in this case. Okay, so because it was 2, or else okay, I'll do one thing, 2 plus 1 I'll write, okay, is 3, because this step I don't have to remember anything, I just have to remember that okay, whatever is there I have to add 1 to that, that's it, nothing else. And I can keep on doing this week by week by week till the time I go and I see here that the buckets are like here, like that, and say here it's already 100, okay, and by that time here also it would be 100, because 99 plus 1 would have gone there as 100, because this check would have brought us here, and this 99 plus 1 is equal to 100 would have gone there, okay. But then once we reach here, and then next week we will ask about this, right, whether it's done. Then the answer is yes, it's done. Then we don't have to do anything. By that time, this bucket, whatever is there, is we just have to pour that out, and we will get the answer, okay, because by that time we would have added numbers there, and then the thing will be done. Now, so this thing, if you write as a very small informal algorithm, which I was talking about, you will just say that, okay, I'll write it here, okay. So what is our algorithm? We are taking two buckets, bucket 1, bucket 2, okay, and then check bucket 2. If we haven't reached, okay, then if no, that means if we haven't finished yet, then bucket 2, you add 1, okay, you put 1 to the bucket 2, and then whatever number that is, you add to that to bucket 1, and that's it. So, and whatever has been done here, this much, and now you go back to check B2. That's it. So that's how you think about repetitive steps, and then it's done, okay. And keep this thing in mind, and we will take only this portion and start writing our first code once we get into. So we will take up this as our base model of algorithm, and we will convert this exactly these steps into our first code once we get into MATLAB, okay. Yeah, then suppose we instead of this we have a problem of say adding like 1 plus 3 plus 5 plus 7 plus 9 plus like that up to 99th term, whatever that is, okay. How would you do that? In the form of I'll break it here otherwise, because it's getting, I think, longer, 15 minutes, beyond 15 minutes. So I'll stop here, and then I'll put that as a next segment where I'll do this, because a lot of things to be discussed about this point, whether it is 99th term or it is 99. So there will be a little change in thought process. So I'll discuss that in the next segment. See you.